Now, item B, intrinsic geometry, exterior algebra, extend to R3 and R4. B, part 3, this case, miscellaneous topics in intrinsic geometry, extend to extrinsic geometry. Now, this example here will make that you will understand clearly what we did for the Legendre transformation. You see, then you used f of x. Now I'm preparing to move to the Legendre transformation of Lagrangian to Hamiltonian, and then relate Hamiltonian with the Lie bracket. Okay, that's our focus, our goal. Now let's see this example here. Is one, using the function f of x is equal to x squared, compute its Legendre transformation. Now, step 1, compute derivative slope of the tangent line. Don't forget from the previous lecture 5 in this case. Now, step 2, then I take the derivative here is 2x. Then I invert. This is x function of p, which is p over 2. You see, you just isolate x over here, this is p over 2. Now, step 2, define the Legendre transformation g of p. G of p is p, attention now, x function of p minus f x function of p. I just substitute clearly. So in this case, this is x, you see here, this is p over here, this is p over there. xp is p divided by 2 minus now f of x of p. You see, that's p divided by 2 is square, so it's p squared divided by 4. Then the Legendre transformation of f of x is equal to x squared is gp is equal to pi squared divided by 4. So they just follow this lecture 5a and b, and this is the application. Now let's go to find the inverse Legendre transform. So step 1, define the conjugate variable here from the function g function of p. Now is the inverse. You see, let's define. You see, this is x will be here is a dg divided by dp, analogous to p is equal df of dx. Now x is dg over dp, is the derivative, okay? And invert to find p as a function of x. Attention now, here I want x function of p. In this case here, I want p as a function of x. It's just the inverse. So x is equal, you see, the derivative of g respect to p, in this case, then p, now p is a function of x. You see, exactly is analogous to here. Here is x function of p. Now here is p as function of x. Then we define the Legendre transformation as f of x, attention now. You see, you always make the analogy. You see, g of p here. This is x, so this is p. This is p of x, this x of p. This is x of p. You see, it's interesting. You just copy from here and substitute, okay, as I'm pointing out over here. So this here, attention on this here is from here, just for you to grasp the idea. Then from g of p, p squared over 4, you differentiate, you see, just to obtain x as a function of p. Now you can, in this case, you just substitute over here, you see, the invert x is p divided by 2, is over there. Now, then, this case, plug into f of x is just here, plug here, into here. So I just substitute these numbers, x, p of x is x times 2x, you see, p of x now is 2x, is equal to x squared. And g, function of p of x, you see, you just substitute, this is p squared, but p is 2x, so 2x squared divided by 4, which is x squared. Now we plug this on here, on f of x, or here, you see, this leads to 2x squared minus x squared, which is x squared. So I recovered f of x. You see, that's an example just to clarify our next step. It will be now f function of two variables, f function of x and y, for instance. Okay, that's it.